Okay, welcome back to your next lesson on magnetism. We have already covered magnets and their properties and magnetic induction, and now we're going to move on to magnetization and demagnetization. Okay, but in order to understand this topic, actually what is important is the concept of magnetic domains, which we covered in the previous topic. So I'm just going to quickly just revise that again, right? So this idea of magnetic domains, that magnetic material is made up of several domains, where each domains have like little magnets. These things are like atomic magnets, and all these little tiny magnets all point in the same direction in a domain, right? And what gives it its magnetic property? When all of these domains are aligned in the same direction, this helps to this is what gives it its magnetic property, where it becomes like a magnet, or basically it does become a magnet when they're all aligned in the same direction. Then north pole is here, south pole is here, in between here it all gets cancelled out. The effect gets cancelled out because you see south and north, so cancel south and north, cancel south and north, cancel. But down here you get a very strong south, down here you get very strong north, so you get a south pole and a north pole in the magnet. Okay, so it's when all of these dipoles are aligned that you get a magnet. Typically in a magnetic material that is not a magnet, all the things are misaligned. They are arranged in they are basically just misaligned, and so the magnetic effect just gets cancelled out. There's no strong pole in any direction. Okay, this is an important idea as we talk about magnetization and demagnetization. Okay, so moving on. Yes, remember the meme. Anyway. Okay, so magnetization and demagnetization. What we're going to learn is how can we magnetize a magnetic material, and how can we demagnetize magnets. Okay, so how can we magnetize magnetic materials, and how can we demagnetize magnets? Okay, the key principle here, as you might already guess, in fact if you can guess now, the key principle here is aligning or unaligning the magnetic domains. Okay, because that is what gives it its magnetic properties, right? So aligning or unaligning magnetic domains. Okay, so magnetizing magnetic materials, yes, the key here is aligning magnetic domains. Okay, the key here is aligning magnetic domains. So how do we align the magnetic domains? One way that we can magnetize magnetic materials, I'm sure you've learned this in primary school, is to stroke and unmagnetize steel bar several times with the same pole from one end to another in one direction, using a magnet, of course. So if you see here, the magnet should come, it should be stroked here, and then when it's lifted up, it needs to be lifted high up and then back down. Okay, why? Firstly, why does stroking it make it a magnetic material? What do you think? Okay, so you know this, all the domains, right? All the domains, south will be attracted to the north pole, and as you stroke the north pole across, what will happen? All the south poles will be dragged along to point in this direction, right? All the south poles will be pointing in this direction. So if all the south poles point in this direction, okay, so I was saying if all the south poles point in this direction, so it's a bit confusing, but let me draw the magnetic dipoles. Okay, the little magnets. Okay, so little magnets, remember the arrow always points north, right? So all the south poles, if they were facing anyhow, let's say previously they were facing like this, when the magnet gets dragged across, what happens? The south pole will face here, right? Because the north pole is being dragged across, and then the south pole will face here. So this dragging process turns all of these little magnetic domains, it makes it all face this direction. You get what I'm trying to say? Can you just imagine dragging, then everything just faces there, right? So this is what you're doing, you're aligning the magnetic domains. Okay, and then why must you lift it sufficiently high before you come back down? Okay, the reason for that is that if you don't, and you just let's say you drag it across and then you just move it like this and move it back, what are you actually doing? The magnetic field might still be close enough to be attracting the south poles, right? So if let's say you dragged it across and then you lift it up just like here and you moved it back, then all the south poles start to turn away again. right? So you just keep reversing the process every time you stroke it, all face one direction, then you move it all face the other direction again. Okay, so what you need to do is to stroke it so they all face one direction, lift it very high until the magnetic field is not affecting the pole, so that you can move it back here to stroke everything to face even more aligned. Okay, to catch all those that you didn't move fully. Okay, so that's the principle of stroking here. Stroking will help to align the magnetic dipole. So this is one method of magnetizing magnetic materials. Another method of magnetizing magnetic materials is the electrical method using direct current. Okay, so this is something that you actually learn in the next half of this chapter, which is the electromagnetic effect. But basically, you will soon find out that electricity and magnetism is super interrelated. And one way it's interrelated is that when you have a coil of electricity, basically a current flowing through a coil, it would produce a magnetic field in a certain direction. Okay, so just take it as is for now. Basically, when there's a coil with current flowing through, you can see there's a coil with current flowing through, it would produce a magnetic field in a certain direction, and because it produces the magnetic I haven't taught you what magnetic field is. Ignore magnetic field. It will produce a magnetic effect. Okay, it produce like a magnetic effect, like a north pole in this direction. Okay, so basically, this coil will produce a north pole in a certain direction, and by producing a north pole in a certain direction, it will cause all the dipoles to turn to face this direction as well in an object. All the domains to turn and face this direction in a certain object. Okay, so you by placing a steel bar inside a solenoid. A solenoid is basically a coil, current carrying coil. Current carrying coil is a solenoid. So when there's current flowing through this coil, it's a solenoid. By placing a steel bar inside, all the magnetic domains in the steel bar will be aligned to a certain direction, and it will make this a magnet. Okay. So determining direction of the solenoid, I will teach this in, I'll revise this again later, but basically there's this thing called the right hand grip rule. Okay, the right hand grip rule. The right hand grip rule tells you which direction will the north pole be in a solenoid. How do you do this? It's very easy. Grip the solenoid using the right hand. So the solenoid, the fingers should be curled in the direction of the current flow. So can you see when you're looking from the front from this perspective, the current is flowing downwards, right? The current is flowing downwards. So when you grip your fingers will be facing downwards. Always use your right hand. That's why it's called a right hand grip rule. Okay. So in this case, there's no good way of showing you this. So I'm gripping the solenoid like this. So imagine there's a solenoid here. I am gripping the solenoid this way. I actually just look at the picture lah. Okay, I'm gripping the solenoid this way such that my fingers are curling down in front of me, and then when you grip it this way, your thumb will point in the direction of the north pole. Okay, so by gripping the solenoid this way, this side is the north pole. Okay, don't worry, we'll revisit this again. Okay, but basically the main thing you need to know from this is the first method is stroking. The second method is electrical method using a direct current. When you put it in a solenoid, when you put a steel bar in a solenoid, it will align all the magnetic domains in a certain direction. This direction is given by the right hand grip rule. Okay, great. So that was magnetizing magnets.